In this video, we will be discussing how to use Vernier graphical analysis to create a graph. When you open Vernier graphical analysis, you should see this screen. The top option here is if you're collecting data with a sensor like a force probe or a motion detector. Here you can share data, but for us, we are going to be doing manual entry. We'll be choosing some data and entering it in by ourselves. So choosing that option pulls up a screen that looks like this with a graph on the left and a data table on the right. Here's my data set over here. I am going to go ahead and graph data for position as a function of time, which means my independent variable is time. That's going to go in this X column here. I'm going to rebrand it as time by clicking on these three dots and then choosing column options. This will let me rename this as time, which has units of seconds. And then I can press apply there. Now this column is labeled as time. Here in this column, I'm going to click the three dots again, column options. My dependent variable in this experiment is position, so I'm going to write out the word position, and position is measured in units of meters. So I'll put an M there, and again we'll press apply. Now I have time, and I have position data. And if I have multiple data sets that I'll be plotting, you may want to rename the data set up here too. You don't have to, but I'm going to choose to keep myself organized. I could rename this data set as glider data 1. And if you have more than one glider data, you could do glider data 2, 3, 4, etc. And now I'm going to type in some data. This is something you've collected somehow, maybe doing video analysis, maybe using a motion detector. I'm just going to make up some numbers here. I'm going to say I collected data every second, so I'll go 0, 1, 2, 3, 4, 5, 6 for my times. And let's say my position at time 0 was position 0. At time 1, my position was 1. At time 2, my position was 4. At time 3, my position was 9. At time 4, my position was 16. At time 5, my position was 25. And at time 6, my position was 36. So here are my data. You can see I chose a quadratic relationship here, and so we have a nice parabola. As I look at this graph, I can see that I have time, my independent variable, plotted on the x-axis, measured in seconds. I have position, measured on my vertical axis, measured in meters. The units are there in parentheses. Now, this is a pretty good graph. To upgrade it from good to great, there's a few things I need to do. All of the additional things I need to do can be found in this Graph Options menu in the bottom left-hand corner. The first thing I want to do is apply a curve fit. If your data is linear, you can choose the linear option, but I don't have a linear curve here, so I'm going to choose one of the other options here. For us, we're going to choose proportional, linear, quadratic, inverse, or inverse squared. Those will be the 5 that we are going to use in this class, never power. So quadratic, if I click that, I can see I get a perfect fit to my data because I chose the numbers to be perfect, but you'll get something that's pretty close with real data. And I'll press apply. And here we can have, we have a box that we can click and drag and move around out of the way. That tells us the quadratic equation that they plotted, which fits this data. Quadratic equations in general are ax squared plus bx plus c, and the coefficient a has a value of 1 in this parabola. The coefficient b has a value of 1.78 times 10 to the minus 16, which is basically 0. And the coefficient c also has a value very close to 0, negative 5.832 times 10 to the minus 18. If I were writing down a mathematical model, I would choose to leave the coefficients b and c as being 0. This RMSE number stands for root mean square error. You can pretty much ignore that for our analyses, but if this number is smaller than 5% of your maximum y value, then you're usually in pretty good shape. It's kind of a helpful thing to look at there. So there we have our quadratic fit. The other things we want to do to make our graph great are make sure that the origin 0, 0 is visible. That's the case here, but in case it weren't, how you would change that is go to Graph Options, and then you would choose Edit Graph Options. And you can choose your x-axis range and your y-axis range scaling. We don't want them to be automatic. We want them to always show 0. So we'll do that for x-axis range, and we'll do that for y-axis range, always show 0. And then the origin should always be visible. You'll want to double check that you have points selected and not lines or bars. Lines we can see plays connect the dots with our data, which we never want. And bars we don't want either, because we don't want bar graphs. The last thing you'll want to do under graph options is give your graph a title. That graph title is always going to be what's plotted on your y-axis, which is position here, versus whatever's plotted on your x-axis, which is time here. So vertical axis versus horizontal axis. And you do not need to include units in your title. Once you have a title, always show 0 selected for both your x and y axis ranges. We can X out of that. And now we look and say, cool, we have a perfect graph for our data. Now we're going to want to save this both as a graphical analysis file in case we need to come back and edit it later or use this data in any way, but then also as a graph image that we could upload to Google Classroom or a lab report or whatever it may be. All of your saving is going to happen in the top left corner here with this folded over document sort of image icon. We'll click on that. First, you will save as, and you can save this however you want. They'll save as a .gamble file. I'm going to call this example_graph. And saving it to my document seems like a great choice, but you can choose to save it wherever you want to on your computer. And now I have this file that I can go back and edit it if I need to. Finally, do not take a screenshot of this for your graph image because the screenshots don't look very good. Instead, you'll go back up to the menu in the top left corner and you'll choose Export. From here, you should, in a moment, get a very nice looking graph image. If this box is covering up a small part of your data, that's okay, but it'd be better if it weren't. So I'm actually going to leave this and choose to drag this over here more, and hopefully that's no longer covering up our graph. We can go back now and go to Export, which was in the top left menu here. Let it make a pretty looking graph, and now this is perfect. Our box telling us about our curve fit is not covering up our data or our graph at all. I can see my x-axis label and units. I can see my y-axis label and units. I can see my title. And I can see 0, 0, the origin is clearly visible on this graph. You have some options on the right here. You can choose to make the line shading darker if you'd like. You can make the axis labels larger, which is kind of nice sometimes. And then you can change your graph shape aspect ratio if you want. But from here, you press the Save PNG button. Give it a name. I'm going to call this sample_graph.png, and I'll save it to my downloads. Sure, why not? You may want to save it to your Google Drive or something like that, wherever you want that makes sense to you. From here, this graph is ready to be uploaded to wherever I ask you to put it. And so you can put this image in a Google Doc lab report. You can put it on Google Classroom somewhere. You have this image. If I X out of this, and pull up the image from my downloads folder, here it is, samplegraph.png, I can see this picture looks nice and pretty. And that is how you create a graph on Vernier graphical analysis.